Okay, welcome to iLecture Online. In our next video here, we're going to talk about how to find the components of a vector. Given a vector, let's say here velocity, the magnitude of the velocity is 30 meters per second, and the velocity is directed in a direction that's 30 degrees above the horizontal. So what would be the x and the y component of that velocity? So first let me draw what those components would be. Here I can draw this line, this vector right there, and notice if I drop this vector down to the horizontal axis, the length here represents the magnitude of the x component in the direction of the x-axis. So I can say that this here is v sub x. And then if I draw a dashed line, the imaginary y-axis here, then this would be, there we go, that would be our y component, v sub y. Notice since they both have little arrows on top of the v's, that means that they're actually representative of vector quantities. And then of course, again, I can move any vector around anywhere I like. So I'm going to move my y component of the vector over here, because that makes it easier to see. So I'm going to move that over here and call this my v sub y. Now, what are the magnitudes of those? If the velocity itself is 30 meters per second directed to the upper right corner, so to speak, what would be the magnitude of v sub x and the magnitude of v sub y? Well, that's the key of this video right here. So v sub x is equal to, now, notice I didn't draw a little arrow on there, so I simply talk about the magnitude only. And notice this triangle right here where the hypotenuse is the magnitude of velocity, the adjacent side to the angle represents the magnitude of the x component, and the opposite side to the angle represents the magnitude of the y component. So since it's adjacent side, I can say that v sub x is equal to the hypotenuse v times the cosine of the angle theta. Likewise, I can say that v sub y is equal to v, which is the hypotenuse, times the sine of theta. And that's how we find the x and the y components, at least the magnitudes of them. So this is equal to 30 meters per second times the cosine of 30 degrees. And this is equal to 30 meters per second times the sine of 30 degrees. Okay, now the sine of 30 degrees, that's easy. That's 1/2. So 1/2 times 30 meters per second would be 15 meters per second. Now what about the cosine of 30 degrees? Well, that's 0.866, and see here, I have my calculator handy. Let's find out what that's equal to. So we have 30, take the cosine of that, and multiply times 30, and we get 25.98. That's close enough to 26 meters per second. So now I have the magnitudes of the x and the y components of the velocity. So if I want to write that in a vector format, I can write that v sub x is equal to the magnitude, which we have here, 26 meters per second, and times the unit vector in the direction that it's pointing. And since it's pointing in the positive x direction, I write that as the unit vector in the x direction. V sub y is equal to, in this case, it would be 15 meters per second. And since it's pointing in the y direction, I'll draw the unit vector y. All right, now if I want to write the whole vector v, I can do that as a sum of its x and y components. So I can say that v is equal to v sub x plus v sub y. In other words, I can write v as 26 meters per second, which is the magnitude of the x component in the x direction, plus 15 meters per second in the y direction. Now, some people don't like x and y hats. They like I, j, and k. So you could write this as v is equal to 26 meters per second in the x direction. I'll write it as an I, plus 15 meters per second in the j direction. And I just kind of made a wrong squiggle here, j direction like that. So either way, it's exactly the same thing. So you can see that both notations work. But this is how you write the vector in vector format. Magnitude and direction of each component summed together give you the whole vector. And if you want to write the components by themselves, then you would write it like this. Either use x and y or I and j. And that's how you find the components of a vector. always related to some origin and perhaps an x and a y axis. Now notice this is only in the two-dimensional plane. We can also do the same in a three-dimensional plane. You'll see some examples. No, I shouldn't say three-dimensional plane, three-dimensional volume. And you'll see some examples of that in some later videos.